This is a basic Python programming tutorial for beginning or intermediate Blender users. I'm using version 2.63a, and what we'll do in here is we'll just add some objects to the scene programmatically. And because sometimes when I like to work, it's like, you can either do it through the array modifiers or just carefully placing objects, but to mathematically place the objects for me is really a much more powerful way to work. So I'll step you through it, and we'll use this basic scene that I have set up here. I just have a plane and a couple of spotlights and some point lights as well, just because I like to have a nice scene to look at. And the one thing, make sure that you have your texture mode set. If you're not familiar with that, you might take a look at my video on basic particle launcher. And you also have to have gone into Blender game mode so you can set the lighting. Let's see, where is it over here? Under the render button down in here, you have to set the shaders, GLS cell shaders, like this, in order for your texture lights to come into effect. But we're not going to be working in Blender game mode. We'll be working in Blender render mode, and that's where we'll be writing the Python script. And there's a difference in Blender. It's kind of like two distinct engines. You can either program within Blender render, or you can program within Blender game. We'll be programming within Blender render. The scripts are different. The programming is different. So you don't want to try and mix and match. So we'll just stick with this one for starters. So when Blender starts, you end up looking at this particular window like this. You have your timeline down here, and your menus, and your toolbar, and your main window, and that's your default mode. So if you click this button right here, we'll just switch over to scripting mode, and it's really just a different layout on the screen. And I've added, you can kind of change your menus at will, but it comes up with a text screen where you can type in your code, which I've done in here. And it comes up with with this window right here, which is your Python console. And then it has this other window was your info window, which I had picked from up here, right, like this. And this is all really powerful stuff. And the other thing you want to have is you want to go up into your help screen, help menu up here, and you want to toggle the system console. Click that, and that'll give you a window, and what that does, that is the location where the output of your programming goes to. So if you have an error in your code, it'll show up in that console window, and you'll have to pick that up off the taskbar. But it won't show up in this console window here. Alright, this is for a different reason. In fact, I'll just show you a few things. Before we get started the programming, I'm just going to move my cursor to this location, and we'll keep an eye on this info window for starters, and I'm just going to add a cube to the scene. So I'll Shift A, and I'll add a cube right here. Okay, so now what happens when I added the cube? If you look here in the info window, it shows you exactly what it did. It executed this command bpy.ops.mesh.primitive.cube add, and then here's all the parameters that it can accept. So here I can tell, oh, these must be the layers. See, layers equals false, true, 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 false, 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 false. So it shows you the layer that gets added to, which we are on layer 1. I'm quite sure if we look back in the other window. There's 0, 1. It tells you the location. That'd be the location where my cursor was right here. And edit mode is false, etc. So it's really a nice way to find out what's happening, because you then end up using these same commands down here within the programming language. So for instance, up here let's get started in this window here. I'll just start, let me sync that real quick. No, that's from, we'll just make that separate like this. Don't worry about that. That was just something I had done earlier. So I'll move this over just a little bit for the moment. When you program in Python, there's a couple things you can take advantage of right here. Numbers. Notice I turn this on and off. It gives me numbers to look at. I always have that on. Here is wraps the line automatically for you. And this one is highlighting of keywords like programming words, variables, things of that nature. So I always turn all these on. They're off by default. And the other thing is, when it first comes up, it comes up with a blank screen right here, like this. If I could click this, there's my file right there, but we'll make another one as well. But it comes up with this blank screen like this, and that's where you actually type. So what I had done, I had created a file by clicking this plus button here. And see, it comes up with text 001. But I had just gone in and typed a new name, a new name in here, like that. And then that's where I typed my code. And then to get to it, you just switch between. See, there's the old text, there's a new name, nothing in it, and there's my file here. So I had named it this with the .py extension for a .python extension. And then you can save your text file as you go separately by saying text save as right here and save it anywhere on your hard drive. Alright, so let's get coding, and what this does, we're just going to simply program some simple primitives in a circular fashion around the screen so I can place them where I want. And these are really important steps. Just enter in these 3 lines for starters. These are just absolutely critical. This is the most critical. Import BPY. This is like the main import file that you need, which covers everything underneath it. Because you notice here when you added a cube here, it starts as bpy.ops.mesh .primitive underscore cube add underscore add. And so you'll need, just type in these 3 lines for starters. You'll need these 2 for the Python in Blender, and then you'll need this because we're going to use some math routines as well. From math, import sine, cosine, radians. You don't have to worry about so much what they do immediately. We'll just get to them because a lot of easiest ways to code is to just start implementing the code. You kind of look what I'm doing, you type it in, you see what it does, then you go make small modifications to your code, and pretty soon it becomes easy. But just as long as you have those in there for starters, you're in good shape. All right. Now once you have that, this bpy.ops.mesh is what I use down here. See, I defined it as cube object is defined as this, and then later on I use it down here. So this really is the same as saying this bpy.ops.mesh primitive cube add, and then with a location. So that's just kind of a pre-definition. And then the cursor is cursor equals context.scene.cursor location. This allows me to click in the scene. And it's really cool with Blender. You kind of like you're working with your code, but you're interactively working with your design. It's really powerful. So you click in the scene, and then what I'm using this for is when I'm actually plotting something to the screen. I'm going to use it later down in here. I'll pick up this cursor, these cursor values X, Y, and Z, and I'll use that location to plot what I'm doing in the programming code. All right, but we'll get to that. So these are just kind of pre-definitions, variables that I'm setting up in advance. These are another variable I set up. The radial distance I set is 1.0, kind of as a default for like if you're using a unit circle in trigonometry. We'll cover that here in just a second for those of you who are a little rusty on your trigonometry. And this X size, Y size, Z size, initializing more variables. That's just I'm using a default size of 1. I won't use those initially, but I'm just setting that up. Theta I set as 0. I'm going to use that. Pi over 8 I'm just setting as a kind of a rough approximation to pi over 8, and that's actually should be pi over 8 is going to be 3.14 divided by 8. All right, so that's pi, the value of pi divided by 8. So I just set it up as a variable as pi over 8. All right, but let's actually make that let's make it 2 pi over 8, and that's why I had 6.28 in there, because that's really what I wanted. I wanted it all the way around the circle. So we're going to go take a look at some math here in just a second before we get started, because within Blender, when you do rotations, things like that, we're frequently working in radian mode instead of angles. And I know a lot of you, maybe when you start Trig, it's like, why not work in angles like 0 and 45 degrees and 90? Why do you have to work in radians? Radians seems kind of distant and a little confusing. It was to me when I first learned it. So let's just take a look at this math program before we continue. Alright, so over here, here's my little math instructor program. And in this, it's a calculator and a plotting programming language, the whole 9 yards. But it's working in degree mode right now. So when your angles in mathematics, 0 degrees starts over here to the right, 45 degrees is here, so your angle is like this. 90 degrees, here's your 90 degree angle like this. 135 extends out to this. So it's just an angle of measure as you're going around the circle like this. So if we're picking up points, I want to say if I want to find a location here in coordinates, I need to know this angle at 45 degrees. That's where we use the cosine and the sine functions. But if since we're going to be using radians in this calculator, I'll switch to radian mode, and you can see it's just an angle of measure, but just with different values. So instead of saying 45 degrees, I say 0.785 radians. Instead of 90 degrees, it's 1.57 radians. So here's 2 pi all the way around the circle. It's really 2 times the value of pi, so 2 times 3.14 is 6.28. So if you notice on here I'm just setting 2 pi over 8 to be an angle of measure. I'm really just saying, in this case, 2 pi is 6.28 over 8, so I'm dividing the entire circle up into 8 different angles, so I'm really saying the same as a 45 degree angle, or 0.785 radians is going to be my increment. So that's just the variable that I've set up in advance. And if you're not really familiar with radians and trig and things of that nature, I highly recommend that you go watch a number of the math videos that I have posted. One in particular called Just What is a Radian. You can even type that in under YouTube and you'll find it. Or I'll put a link at the end of the video so you can see some of it, and then that'll help you. But the essence of it is that, if you're trying to, let's just do it in degrees for the moment. You say I take a 45 degree angle, and you enter in the angle for my angle down here, and I take the cosine of 45 degrees, it returns a value of 0.707. Well, what that is, since the cosine represents your x-coordinate, so I'll put that in there. That's 0.707. And then since I still have the 45 degree angle, I can take the sine of 45 degrees, and it's also 0.707, and that is my y-coordinate. So really it means you're going up 0.707 on x and 0.707 on y, and at that location you get your location to plot in Cartesian coordinates. Alright, but let's get back to the lesson. Let's see. So now what I've done in here, then I run into a loop. So what I'm saying is, while theta is less than 6.28, so really what I'm saying is, while my angle theta is less than 6.28 radians, which means it's less than the whole way around the circle, I define my x value to be the location of the cursor plus this radial distance times the cosine theta. Now this is the important part mathematically, is radial distance times cosine theta, which is really, maybe you've seen it as r cosine theta. So we've taken the cosine of theta, which, just like you've seen before, is 0.707, and I multiply it times the radial distance. In our case, I set the radial distance as 1.0, and then this portion of it here, I'm just translating the resultant value based upon where the cursor is located. So that really doesn't have much to do with the calculation of the plotting something around a circle. It's just based on where the cursor is located. And then I take once I get my x, y, and z values, then I call this cube object, which is, remember, this BPY. So that's cube object, and I provide a location with it, because you can see in here, here's location equals. So I provide the location as my x, y, z value variables, and that plots it on the screen. And then I come down here and I type in theta plus equals pi over 8. So I've incremented my theta variable by a value of pi over 8, but in this case I want 2 pi over 8, because that's really where I was, 2 pi over 8. So since we haven't tried it, oops, let me see, gotta get my mouse back in there, like that. In fact, I'll save that. Like this. And then theoretically, what happens is, if I click in this window, wherever my cursor happens to be, maybe I'll just click it right there. And I'm not sure where that is, but we'll just click it there and we'll just see what happens. And then we can run the script. So let me see, where's our run script? I'll move this over. It's over here, run script, like this. I'll just click run script and see what happens. And do I see anything? Well, let's see. I see something there. Let's see. Let me go look at it from above. Let me. I'll just control up arrow, and that way I can see it from above. And maybe I need to move the mouse cursor up there. Let's see. Oh, it put a cube there. Oh, it put a cube. It was underneath the plane. Let's see if the plane's in the way. Let's move the plane out of the way. Oh, there they are. They're down below the screen. So the problem was, in that case, my cursor was actually, I should have looked at my cursor. So we'll just add another one. Heck with that. We'll just put the cursor over here. So I know it's above the plane. I can just run it again. So control up arrow, go back to here. I run the script again, and there placed something there. Now let's see. Let's look at it from above. 7, full screen, and I'll hold the shift key and move the thing down, and let's zoom in. So what it has done, and it's kind of hard to see at this point, is it's actually taken 8 cubes and placed them around a circle. Now my cubes are too big for starters to notice it, so what we'll do is we'll change that up a little bit, and I'll increase my radial distance. So the cube is so big that you can't really see the individual cubes being plotted around the circle. So in this case, I'll make my radial distance 5. So it's going to be 5 times whatever this cosine theta is. And let me just move I'll just move it over here a little bit. I'll just put my cursor there. I'll just run it again. Okay, and let's go into ortho mode and see what we have. We'll move it down here. Let's grab a light. Shift D, I'll copy light. I'll move a light over here so we can at least see something going on. And I better move that light up so we see above it. Like that. We can kind of see it there. So so there it is. We placed all 8 cubes, 1, 2, 3, 4, 5, 6, 7, 8, around the circle based upon this simple loop. And then you can just place them anywhere. Unless I erase them, I can just keep placing them here. I put one there, I'll place one there, I put one there, I place one there. Alright, well that kind of gives you an idea as to how to get started. And you'll notice in this case I use the while loop. While theta is less than 6.28, ends with a colon. I didn't use a for loop because for loops don't handle floating point numbers very well, but you could of course scale a number up with the for loop, but it's just as simple with the while loop whenever I run it. And if you're not familiar with Python whatsoever, the way it controls this is when you type in this statement, then everything that's indented here by a tab, like I'll back this up, I hit a tab, and that indentation is critically important in Python. So one tab in tells me that things within this loop, the while loop, get executed. So that gets executed, that gets executed, that gets executed. All these get executed within the while loop, and then notice this is back at the beginning line. Those don't get executed until the while loop completes. So I say while theta is less than 6.28, I get these values of x, y, and z. Then I increase theta by my value of 2 pi over 8, and then it goes back and checks. If it hasn't continued on, when it finally reaches that location, then it pops out of loop and continues down the road. Alright? Well, I hope that gives you a basic idea of how to use it. And there's one other thing you can look at right over here in the console window. And this is not the same as the programming console window. In fact, maybe I can pop up that programming console window real quick and show you. I don't have it running right now, so I'll get it running real quick. Help. Here's this console, the system console like this. Right, so that'll tell you what's happening within your programming code. Alright? But this console allows you to look at, say, the value of things like, for instance, a cube object is this bpy.ops.mesh, so I can just type in down here, well, let me see about dir, and then I can put in parentheses bpy.ops.mesh, and it'll give me everything associated with that one. Or if I just type dir, in fact, you didn't even see it happen because it happened, but it just replicated what I did before. I guess I've done the exact same one before. So let's just do dir bpy. This is kind of a level above it, and it'll tell you all the things associated. So there's bpy.ops. So that we have there, we could have done bpy.data. We'll just do that. dir bpy.data, and we get the information associated with that. So that's so by doing things within here, you can see the results, or you can find out information here, and then you can use it to add it within your Python code. All right, well, if it's a little bit confusing, it's understandable. Python's a little complicated at the beginning, but I'll do some more lessons here in the near future, and I hope that helps you get started. All right, well, that's it for this lesson, and I'll see you in the next lesson.